yeah, I want to continue with the work package overview. And my task now will be work package 4 about I/O and data flow. So first of all, what are, just to remind the objectives and aims we have in our work package to help the overall objectives we have in the project. So first of all, we want to have a look on the improvement on I/O accessibility. So here we mainly have the PDI interface in mind. So to integrate the PDI interface into the applications to decouple existing I/O libraries from the application itself. And for this, we need various types of PDI backends, so different types of I/O libraries or also of other data flow libraries here to be added to the PDI library. Our second objective is about I/O performance, so how to improve I/O performance of our code. So we have, on the one side, of course, to leverage the capabilities of the existing libraries in use underneath of the PDI interface, taking care of asynchronous I/O operations, so whenever possible to run I/O directly at the same time as you have, for example, computational operations. And finally, adapting intermediate storage elements, because such type as flash storage become more and more popular, especially if you look to for an exascale approach or an exascale system, new types of storage elements gets relevant to just have the capabilities to run I/O on such a large system. Then we have the big point of resiliency about fault tolerance for ensemble runs and also for large checkpointing files in general. And finally, how to reduce the overall data size about in-situ handling and in-transit data compression. We have 4 objectives, so we also end up with 4 tasks here. And now I want to give a short status update of the task and what was the status now in month 8. First of all, on the data interface, we had quite a number of PDI improvements within the first 8 months. So we improved the HDF5 support, which was already implemented within EoCoE, but additional features were added and bugs were fixed so far. There was also updates on the Flow VR interface, where also work was done already in EoCoE. And there was a lot of work going on to supporting more data structures within PDI, so to support C-structs, Fortran-derived data types, and so on, to allow various types of data types to be ported into the PDI library. There was also lots of work going on PDI support, because the applications has to implement PDI within their application. So we want to also offer support from our side to the users or to the application users. So first of all, there was a lot of work on the installation process of the overall library to allow users to install PDI on the system. And we also now have a completely new PDI website in place. So this is currently just a preliminary domain, but I think it will switch at some point also to a new domain name. But the website is already in place. And we also have a dedicated Slack support channel for all questions related to PDI. What's currently in progress? So on the first topic will be the NetCDF support, because we have 2 codes, PowerFlow and EoCoE, which highly rely on NetCDF. So NetCDF will be the next plugin to be added. And there's also some additions on improvement for Python post-processing, so within the Python interface of PDI, and then in connection to WP5 for the Melissa capabilities. About help in PDI integration, because one big topic besides the development of the PDI library will be the integration into our EoCoE applications here. And overall, we had first discussions to specify the overall PDI roadmap. And we had also to start the PDI integration into the Gisela X, which was one of our main candidates due just to the data size of checkpoints created within Gisela. But so far, as you also saw within the WP2 presentation, the PDI integration not started for many of the other scientific challenges. So here, that was also one of our points of discussion this morning in the PDI integration session, how to kick off this activity here. And the target will now to focus on 4 applications. So in the beginning, we have Gisela, where we have a quite close contact with PDI and, of course, the Gisela developers. In addition, we also will focus on Parflow as another candidate for the PDI integration, just due also to the data size. And as soon the developers become available, we will focus on CMAT and ESIAS, because these are the main points to where we see, okay, they have potential aspects in context of data sites, or are connected, for example, to WP5 in context of the Melissa capabilities where we want to use the PDI interface. It is planned to work on, to have a hackathon event to work on these activities in form of a workshop. So here we plan a joint workshop between WP2, WP4 and WP5. WP2 because from the integration point of view, WP4 to have the PDI developers in place, and also WP5 because we are also close connected to the ensemble work. And this workshop is currently planned to have it in November, December. So I will send around a doodle shortly after this face-to-face to find a good place where at least the relevant people has time. So this is the current plan, depending of the availability of the relevant, especially the SC members. So it will be mostly a PDI hackathon, but also in the same amount for the ensemble-related project, an ensemble hackathon. And as already mentioned, we also plan to have a PDI webinar in 2020, so next year. Okay, switching to I/O optimization. This is a smaller task in comparison to the PDI task. However, I/O optimization is a big important task here for the overall work package. And there I want to just show 2 activities which started so far. The first one, we had to shift a little bit from the original roadmap in the sense of that we wanted to directly start with the Gisela optimization due to the changes on the Fusion Scientific Challenge. We slightly delayed this activity. Instead, we added a small other activity which helps us in the overall context by including PDI also into some benchmark application, because what we want to do when trying to all these approaches which we accomplish within PDI, we need to test them. And the best way to test it to have some sort of reproducible setup. So the idea is, which can be easily done, is to integrate PDI also in IOR, which is a very well-known I/O benchmark used for nearly any I/O system procurement, and to use this to, we used it already in EoCoE to reproduce some of the patterns of the applications we have in EoCoE, to use this as a test bed for all our PDI developments here. In addition, as I mentioned, we also need to test on new types of hardware. So having a general file system is what we always do and what we always have, but this will not be exascale in the future. So there will be something in addition, some kind of node level storage, some type of flash or non-volatile memory interface. So something in addition to at least keep track of burst amounts of data or something like this. For this, we are happy to have also DDN within the project and their IME approach. And here we have one task on using their IME approach and integrating it within our SignLib library, which is also or can be used through the PDI interface. So every application which implements PDI is then directly available to use this IME interface underneath. And this is now one first step to start to also take care of this type of architecture. On fault tolerance, we had first activity together with the ALIA code. So here we integrated FDI checkpointing for ALIA by adding the option to store data in a checkpoint and to restart from such a checkpoint. And we also did some work on checking the accuracy of those checkpoints, or at least of a restart, because usually when restarting from a checkpoint, there might be some differences depending on the on the or on the stored amount or of the bytes you store, but as you see, it still produces acceptable accuracies compared to the overrun if you do not had any restart in the meantime. For the last task, which is mostly planned to start beginning of next year, we had some first look in the sense of for the in-transit data compression. Here it is planned to use the existing approach of the HDF5 parallel compression capabilities which are in place and to leverage these capabilities into the NetCDF interface, because we want to use these for NetCDF codes. They are already in place for HDF5, and now we just want to adapt this into NetCDF4 as well to make it available to allow in-transit data compression for parallel codes. Overall, we have no deliverable in the first year, so our first deliverable will be mid of next year in month 18, which will be an intermediate report. So here we are completely on track so far, and the most important thing will now be the start of the PDI work for most of the applications, and of course on the technical aspects within the optimization work. Yep, that's everything from my side. Any questions?